This video is going over the review for quiz 4 on the log properties and solving equations and the change of base formula. So using the given estimates, that is these estimates over here in the table, and the properties of logs to evaluate the expressions without a calculator. So remember, our log properties tell us that if I have the log of x times y, that can be rewritten as the log of x plus the log of y. And it can be any base. If I have the log base b of x divided by y, I can rewrite that as the log b of x minus the log b of y. And if I have the log of base b of x to the k can become the coefficient k log b of x. So these properties are similar to our exponent properties. Multiplication, we add. Subtraction or division, we subtract. And a power, we multiply. So I want to use these numbers or numbers that I know. If it's log base 3, we know that the log base 3 of 3 is 1. And we know that the log base 3 of 9 is 2. We know that the log base 3 of 27 is 3. So we might have to call on numbers that we already know. And it wouldn't hurt on the quiz to write a few of them down so that you can remember that those are options as well. So if I have the log 3 of 8, 8 is 4 times 2. So we have the log base 3 of 4 times 2. And I want to see all these steps, no shortcutting. And that can be rewritten using the product property, log base 3 of 4 plus the log base 3 of 2. And now we can substitute the decimal approximation. The log base 3 of 4 is 1.26. And the log base 3 of 2 is 0.63. And we're going to add that together. And just a little refresher, because you won't have a calculator, when you're adding decimals, you have to line up the decimal places and then add them. So that's 981, 1.89. Okay. Number 2, log 3 of 45. Well, what I know from 45 is 9 times 5. So I can write that as the log base 3 of 9 times 5. Again, using the product property, the log 3 of 9 plus the log base 3 of 5. And we know the log base 3 of 9 is 2. And our table tells us the log base 3 of 5 is 1.46. So my answer is 3.46. And the last one here, we have 2 over 7. So that's our quotient property. Can be written as subtraction. So that's the log 3 of 2 minus the log 3 of 7. And then substitute the 0.63 minus 1.77. Now without a calculator, this is where everybody messes up. To subtract two numbers, I have to put the bigger number on top minus the 0.63. But since my problem is 0.63 minus 1.77, my answer is going to be negative. But I can't set the problem up the other way to get the correct difference. So 7 minus 3 is 4. 7 minus 6 is 1. So negative 1.14 is your final answer. So make sure you do that part correctly. Now the next part is expanding the logarithm, writing it as the sum of logs. Every variable and number gets its own log. And that's not talking about the base. Like this base 2 is not considered a number, it's part of the log. So in this one, I have two variables, a and b, so I should have two separate logs. And I'm going to start, my product property says that can be written multiplication as addition. Log of a cubed plus log of b to the 5th. And then my power property says the exponents can become my coefficients. So I'm going to bring my exponents out front. 3 log of a plus 5 log of b. Number 5, I'm going to apply that exponent first. So ln a cubed squared is a to the 6th. B squared is b squared. Now that's division, so we're going to rewrite it as subtraction. Ln of a to the 6th minus ln of b squared. And again, my exponents go out front. So I have 6 ln of a minus 2 ln of b. Number 6, log 2 of the cube root of b divided by 4a. Now remember, each variable or number gets its own log. So I'm going to have a log for the b, a log for the 4, and a log for the a. I want to rewrite the cube root as an exponent. And we'll do that in a minute, but let's first divide it up. Anything on the top is going to be a positive log, so log 2 of the cube root of b, and then minus the log 2 of 4. Then a is also in the denominator, so it's also being divided, so minus the log 2 of a. And then this is b to the 1/3 power, which means this 1/3 can go out front. So 1/3 log 2 of b. The log 2 of 4 is just 2. We know that. So if you can do the log, you can simplify it and do that. Minus the log 2 of a. Okay, so now we're going to go the opposite way. We're going to condense the logarithm, means we're writing it as a single log. So we're going backwards. Our final answer should look like the problems above. If it doesn't, then we did something wrong. Notice there's only one log in those equations. One log, one log, one log. So we're going backwards. We're here, our exponents became coefficients. Our coefficients are going to become the exponent. So I have the log of 3 becomes the exponent a cubed minus the log of b. Now subtraction can be rewritten as division. The log of a cubed over b. Log is only written once. Number 8, the 1/3 can go on to the a, the 2 goes on to the b, and the 3 goes on to the c. So we have the log a to the 1/3 power, or we can write that as the cube root, the log of b squared, plus the log of c cubed. Now, here, the minus means the b squared is going to be in the denominator, and then the plus on the c cubed means it's going to end up on the top. So any logs that are positive, what's inside those logs go on the top, and the negatives go in the bottom. And we'll write it as a cube root of a times c cubed over b squared. Now we're going to solve equations, and these equations don't actually have extraneous solutions. So we'll talk more about that next week. So we're going to show all of our steps. The first thing we have to make sure is if we have a log or an exponential, we're going to isolate that before we rewrite it. But our strategy is to take the exponents, rewrite them as logs, like we did in our quiz trade, and then take the logs and write them as exponents. So for number 9, 7 to the 5x equals 12, that's isolated, so we're going to start and just rewrite that. 5x equals the log base 7 of 12. Now you can write it the other way if you want as well. Log 7 of 12 equals 5x. So remember, when we rewrite our logs, the base of the exponent is the base of the log, and the 12 goes into the log, and then your 5x is on the other side of the equal sign from the 7 and the 12. So the 7 has to change sides from the 5x. So now I just need to get x by itself, divide by 5. So x is equal to the log base 7 of 12 over 5. Okay, we can leave it like that. If we were to plug it into a calculator, though, which you're not going to have, we would rewrite it with a change of base formula, which says that's the log of 12. And then the 5 stays on the bottom, and then log of the base, so log 7. And that's how you would plug it into the calculator. Okay, but it's okay to leave it like this for tomorrow. So number 10, we need to get the log by itself, so we're going to divide by 4 first. We get the log base 5 of x minus 2 equals 2. And then the 5 becomes the base of the power. So we get x minus 2 equals 5 squared. X minus 2 equals 25. Add 2, and x is equal to 27. Right? So the base of the log changes sides of the equation with the power. Number 11. Okay, again, so one of the things to think about is this x minus 2 is in parentheses, so I have to deal with it after I change the log to an exponent. Same here, the x plus 8 is in parentheses, so I'm going to deal with it second. But down here, the plus 9 is not in parentheses. This minus 10 is not in parentheses, so we'll get rid of it first. So we're going to rewrite this exponent. The 3 becomes the base of the power with the 4, so x plus 8 equals 3 to the 4th. And then x plus 8 equals 81. And minus 8. And x is 73. Number 12. Again, that 7 is inside parentheses. So we're going to deal with it after we convert it. This is log base e. So e is going to go to the other side. X minus 7 equals e squared. And if you don't have a calculator, you don't have to do e squared. So we're wanting the exact answer. So it's e squared plus 7. Okay, so we're just going to leave them like that. We're not going to plug them into a calculator and get a decimal. Number 13. We're going to isolate the e to the 4x, so we're going to minus 9. 3e to the 4x equals 6. Divide by 3. E to the 4x equals 2. And now e is ln. So ln of 2 equals 4x. So 4x equals ln of 2. Divide by the 4. And x equals ln of 2 over 4. You can just leave it. That's the exact answer. And so now this 10 is outside. It's not inside the parentheses with a 6x, so we're going to add the 10 first. Log base 3 of 6x equals 13. Again, the 3 moves to the other side, becomes the base of the exponent. So 6x equals 3 to the 13th power. And that's really large. You don't have to do that without a calculator. And so we'll just leave it as 3 to the 13th over 6. So if it's a really large number that there's no way you would know without a calculator, I'm not going to ask you to multiply 3 times itself 13 times. And so you can just leave the answer like that. Okay. Now, which expressions are equivalent to log 4 of 5? Log base 4 of 5. So this is looking at the different ways we can use the change of base formula. Change of base says if I have the log base a of b, that's the log of any base of b divided by the log of the same base, has to be the same on top and bottom of a. But it's the base of the log in the denominator. Okay? So if we're looking at a simplifies to the log of 5 over 4 using the quotient property, which is not the same thing. B, log 5 over log 4, that's part of the log change of base formula. That's log base 10. The common log, also known as that. C has the 4 and the 5 on the wrong side. The 4 should be on the bottom, which makes D the correct answer. 5 on top, 4 on the bottom. E is not correct because that's just the log of 5 divided by 4. And then F is correct. It could be any base, 2, 4, 6. So F is also correct for the change of base. And So let's rewrite this with common log. So that's log base 10, right? When we don't write the base. So log of the 7 divided by the log of the base. That's my answer. And this one says rewrite with a natural log ln, ln of 9/8 divided by ln of 4. And then our property says we could write that as ln of 9 minus ln of 8 over ln of 4. And there you have it.